warm welcome to the module on intermolecular forces and types of intermolecular forces. First of all, I will give you an overview of what you can expect from this module. Let us start our discussion with one simple question. What are the different states of matter? Yes, solid, liquid and gas. Everyone knows the answer. Can you give an example of a substance that can exist in three different states? Yes, water. It can exist in ice, water and water vapor. Why does this exist in three different forms? This is due to the attractive force between the constituent particles. So, in this module, we are going to discuss the different types of attractive forces. In the case of water, you can see that there are so many water molecules are held together by the attractive force. So, my question is, can you suggest a name for the attractive force between the constituent particles or molecules? Yes, very good. It is the intermolecular force of attraction. The term intermolecular force of attraction means that the attractive force between the molecules. Okay, now I will show some molecules. You have to do one thing. You have to classify these molecules into two groups. Yes, polar and non-polar molecule. What is the peculiarity of polar molecules? We know that the polar molecules possess charges, so it acts as dipoles. From the name of dipole itself, it is clear that there are two poles or dipoles. So, a dipole possesses a partial positive charge at one end and a partial negative charge at the other end. So, we can think about another question. How many different types of attractive forces are possible with these polar molecules and non-polar molecules? Yes, it is three. Which are these attractive forces? Yes, the attractive force between polar molecules, non-polar molecules and a polar molecule and non-polar molecules. And these forces are called van der Waals force of attraction. Now an example, we shall think about the case of HCl molecule. What happens when a polar molecule like HCl comes close to another HCl molecule? You just think about it. When an HCl molecule comes close to another HCl molecule. You can see that a partial positive charge and a partial negative charge resides at the poles of the HCl molecule. That means partial positive charge on hydrogen and partial negative charge on chlorine. So, there will be an attractive force take place between the molecules. How this attraction take place? The partial negative end of the dipole is attracted by the partial positive end of the neighboring HCl molecule. This type of attraction between two permanent dipoles is called a dipole-dipole interaction. So, here HCl is a permanent dipole, so the attractive force between HCl molecules is called dipole-dipole interaction. Next, we shall move on to the case of a polar and non-polar molecules. What happens when a polar molecules come close to another non-polar molecule? You just think about this case. Here also a possibility of electrostatic force of attraction take place between the opposite charge. Now you may think that how a positive charge or partial negative charge arise in non-polar molecules. So we can think about this case. I will give a hint for this. Here also a possibility of electrostatic force of attraction between the opposite charge. How this arises? Due to the presence of a polar molecule, a temporary dipole is developed in the non-polar molecule. So the partial negative end of the dipole attracts the partial positive end of the temporary dipole or non-polar molecule. This type of attraction between a permanent dipole and a temporary dipole or between a polar molecule and a non-polar molecule is called a dipole-induced dipole interaction. So far we discussed the case of attractive force between two polar molecules and a polar molecule and non-polar molecules. The attractive force between two polar molecules is called dipole-dipole interaction, and attractive force between polar molecule and non-polar molecule is called dipole-induced dipole. Now we move on to the next case, that is the attractive force between two non-polar molecules. What happens when two non-polar molecules come closer? Isn't there any possibility of intermolecular force of attraction? I will give you a hint about this. Here also a possibility of electrostatic attraction between the opposite charge. How is it possible? Let us think about it. Non-polar molecules are electrically symmetrical and have no dipole moment because their electronic charge cloud is symmetrically distributed. But a dipole may develop momentarily even in such molecules also. It may happen momentarily when the electronic charge distribution in one of the atom becomes unsymmetrical. That is, the charge cloud is more on one side than the other. This results in the development of an instantaneous dipole on one of the atom. For a very short time, this instantaneous dipole distorts the electron density of the other atom which is close to it, and as a consequence a dipole is induced in this atom, and the temporary dipole of this atom attracts the temporary dipole of neighboring atom. This type of force of attraction was first proposed by a German physicist, Fritz London, and for this reason the force of attraction between two temporary dipoles or between non-polar molecules is known as the London force or dispersion force. These forces are important only at short distance and the magnitude depends on the polarizability of the particle. We shall now think about the special case of dipole-dipole interaction. Let us think about the molecules like HF or H2O, that is hydrogen fluoride or water molecule. Here the peculiarity of these molecules is highly polar HF bond or HO bond is present in this molecule. Then what happens when these molecules come closer? That means when HF molecule come closer to another HF molecule or H2O molecule come closer to another H2O molecule. Here also you can see a type of attraction similar to the dipole-dipole interaction. That means a partial negative charge is arise on fluorine atom and a partial positive charge on hydrogen atom. And when this dipole is in contact with or in close with another HF molecule, there will be an attractive force between these two molecules. That means partially negative end of one molecule is in attraction with a positively charged hydrogen of neighboring molecule. This type of attractive force is called a hydrogen bond. So a hydrogen bond is the attractive force between a partially positive hydrogen atom with a partially negative end of the another molecule. This type of attraction is again called as hydrogen bond. Now we shall compare the strength of different types of attraction. That means dipole-dipole interaction, dipole-induced dipole and London force. As a beginning, we can see that dipole-dipole interaction is weaker than ion-ion interaction. Can you give the answer for this? Yes, in dipoles only partial charges are involved. So we can say that dipole-dipole interaction is weaker than ion-ion interaction. What is the case of this dipole-dipole interaction with the other type of attractive force? That means dipole-induced dipole or London force. We can say that dipole-dipole interaction is more stronger than dipole-induced dipole or London force. First of all, we shall compare the dipole-dipole interaction with the ion-ion interaction. Dipole-dipole interaction always weaker than ion-ion interaction. Why? Can you give the answer? Yes, in dipole-dipole interaction only partial charges are involved. So it is weaker than ion-ion interaction. In the case of dipole-dipole interaction, polar molecules are interacted by London forces also. Thus the cumulative effect is that the total intermolecular forces in polar molecule increases. In dipole-induced dipole attraction cases also, a cumulative effect of dispersion forces and dipole-induced dipole interaction exists. Hydrogen bonds are powerful in determining the structure and the properties of many compounds. Hope you all understood about the intermolecular force of attraction and the different types of attractive force. Thank you dear students. We will meet in the next module.